For this example, we're going to set it up a little bit differently because sometimes these kind of ideas are a little bit harder to wrap our heads around. So looking at this one, an apple orchard has 20 trees per acre. Okay, so we can say 20 trees per acre. The average yield is 300 apples per tree. Apples per tree. So to figure out how many apples altogether in our set scenario, we've got 20 trees per acre and 100 apples per tree. So that would end up giving us 20 times 300 equals 6,000 apples per acre. And we did that by multiplying. But it's estimated that for every additional tree per acre, so adding a tree, the average yield per tree is reduced by 10. So I'm going to plus 1 tree, take away 10 apples. Okay, so in general, we could say that this would be 20 plus t trees would result in 300 minus 10 t apples per tree. So that's kind of how we can set this up, is by a table. We can talk about how it changes, and so then we can create an equation. So in order to figure out the number of apples per acre, we would have to take these two pieces. So apples equals 20 plus t multiplied by 300 minus 10t. Okay, so I just used t for trees. That's why I chose that variable. And a is going to be my number of apples per acre. So you can choose variables accordingly. You don't always have to use x and y like we did in the previous example. Well, once I have this equation here, now I can actually manipulate it to again look back to my question and say how many trees per acre will yield the largest amount. Well, largest amount is another way of saying maximum. So again, we're talking about optimizing. So the first thing I'm going to do is I'm going to expand this equation. So I've got 6,000 minus 200t plus 300t minus 10t squared. I'm going to rearrange that and collect like terms. Minus 10t squared plus 100t plus 6,000. And I'm going to complete the square from here. So t squared minus 10t plus 6,000. Half of 10 is 5, squared is 25. So really I've subtracted 250, so I'm going to add 250 over here. So my final equation is going to look like this. One vertex form, t minus 5 squared plus 6,250. So why did I do that again? Well, going back to the question, I wanted to know the maximum number of apples that I could produce. Well, remember that my output is my apples per acre. Okay, my input is my number of trees. Okay, because we're relative to our variables in the equation. So keeping that all in mind and considering how many trees per acre will yield the largest amount of apples, my final answer, I don't even need to say how many apples it is. I just need to say that T must be 5. Therefore, my total number of trees per acre would have to be 20 plus 5, or 25. And that would be my final answer. So the actual maximum number of apples was not a question that I was asked in this particular scenario. I could have been asked that. It would be a legitimate question to be asked, say, like on a quiz or a test or any sort of assessment. Okay, but based on what I was actually asked for, all I had to do was solve for the number of trees.